Hello everyone, welcome back to Quest 0. Continuing our sessions on projection of planes, we look at a hexagonal lamina today, wherein the problem statement is a hexagonal lamina of sides 25 mm rests on one of its sides on VP. The lamina makes 45 degrees to VP and the side on which it rests makes 45 degrees to HP. Draw the projections. So this particular problem is very similar to the regular case problems that we have been solving, wherein there is no special consideration. Okay, so initially we'll draw the XY line. I prefer drawing it for the entire length of the sheet. Okay, use a HB pencil to draw the XY line. Name it X, Y, VP, HP. Okay, the naming is done with a 2B pencil. Once you have done this, now there are two methods to draw the hexagon. One is you can go with a regular method wherein you will first draw an edge onto the right side, since it is an edge resting case where one of the side is resting on VP. So you will first draw a straight line and then construct a hexagon based on the angle between the two sides on the inside of a hexagon, which is 120 degrees. Or there is one more method which I prefer, is to draw by drawing a circle. So what I'll do is, I'll look at the length of the sides, which is 25 mm. So I'll measure 25 mm with my compass. Okay, and I'll draw a circle very lightly, a circle which is of 25 mm radius. Okay, 25 mm radius circle using a 2H pencil or with a HB pencil very lightly in the VP space, since it is a side resting condition in VP. Then once you have drawn the circle, note down the center point and on that draw a vertical diameter. Okay, very faintly with your 2H pencil draw an vertical diameter, and from the intersection of the diameter and the circle at the top with the same measurement, same radius, 25 mm measurement, cut an arc. Proceed with the intersection of the arc and draw one more arc on the circle. Okay, sorry. Need to take the radius measurement. The measurement has been shortened now. Radius was of 25 mm. Yes. From the top, cut an arc. Cut the second arc as well. Your third arc will fall on the diameter line that you have drawn. So from that, again cut an arc. So now you'll have 6 corners connect. This will be 1, 2, 3, 4, 5, and this will be the 6th. So this completes your hexagon. Side resting condition, naming them A dash. So this should be B dash. This is C dash, D dash, E dash. This will be F dash. And this completes the hexagon resting on the VP on one of its sides. Now I'll dimension the hexagon. Use a 2H pencil. Fill arrows 1:3 ratio. 25. Use a 2B pencil. Okay. Now draw the projections to obtain the top view. Projections will be drawn up until the XY line, and the segment on the XY line between the extreme projection lines will be darkened. Name them. So when you are viewing it from the top, A dash will be visible. So A is without brackets. B dash will be hidden. So write it inside the brackets. F dash will be visible. So F without brackets. C dash will be hidden. C within brackets. E dash will be visible. So E without brackets. D dash, this point will be directly hidden behind E. So D is with brackets or parenthesis. Now the question states that the lamina makes 45 degrees to VP. Measure 45 degrees. Choose a random point on the XY line sufficiently away from the first position that you have drawn. Mark a point on XY line denoting that it will be the point on which A in brackets B, which is nothing but the projection of the side A dash B dash is, and it will rest on the XY line, meaning that it is also resting on VP. So the condition that one of the side is resting on VP is satisfied. Okay. Measure 45 degrees. With a 2H pencil, connect dimension (45 degrees). The dimension I will write it with a 2B pencil. Now, in order to make the entire lamina in its top view is seen as a single line. So we are inclining this single line at 45 degrees to HP. So measure the length of the line AB to ED from the first position. From the point marked on the XY line, cut an arc and also measure the distance from AB to FC. Get one more arc. Okay. Now darken the line between the extreme arc and the point on the XY line. So this makes the projection of the lamina at 45 degrees to VP. In brackets AB, this will be FC and this will be E in brackets D. Now project these points onto the topmost positions. So from F dash, take a projection line and try to keep it parallel to your XY line as far as possible. Probably the next or the one of the problems in the upcoming sessions, I'll try to draw it in a sketchbook or a sketch sheet wherein the grids are available for easier drawing of parallel and perpendicular lines. I'll show you how it is done. So from F, draw a projection line onto the F dash projection line intersection. Don't extend the projection lines unnecessarily. Limit it to the intersection points. Since drawing is also an art, you need to make it look good. So from E dash A dash, draw lines to A. From DB, now connect these points. So this is F dash, A dash, B dash, this is C dash, this is D dash, E dash. Okay. Darken the edges. Okay. This completes the second position. Now the resting edge is inclined at 45 degrees to HP. Now this you can either rotate it clockwise or anti-clockwise, but I'll prefer drawing it or the rotation to be anti-clockwise. So I'll mark a random point again for the third position. I'll draw a 45 degree line onto this. No, okay. See, the observation is when you rotate it clockwise, these opposite edge E dash D dash will come above the resting edge A dash B dash. Hence, you'll have a lot of space on the VP to complete the hexagon. But if in case you are drawing it by rotating it anti-clockwise, E dash D dash, which is opposite side to the resting side A dash B dash, will come below A dash B dash. Hence, it will be approaching the XY line. So you need to make sure that E dash D dash will not cross the XY line while drawing. This is one observation that you need to keep if you are drawing it anti-clockwise. If you are drawing it clockwise, then there is no such caution required. So I'll mark 45 degrees. I'll draw a line which is now I'll take a rough measurement of what the distance is between A dash D dash. I'll try to mark at approximately 90 degrees where it crosses the XY line. Okay, so if this is where approximately the opposite side may come at the extreme location. So I'll try to mark from this location on the 45 degree line that I've just drawn the A dash B dash line. Okay, so from this position I'll mark the A dash B dash. Now once A dash B dash has been drawn, I'll measure the distance from A dash to F dash. I'll cut an arc. I'll measure the distance from A dash to F dash. I'll cut an arc. The intersection point will give me the position of F dash. A dash to E dash, I'll take a measurement. I'll cut an arc. B dash to E dash, I'll take the same measurement. I'll cut an arc. B dash to D dash. Yes, now it doesn't cross the XY line. From A dash to D dash, take the measurement, cut the arc to obtain the intersection. Finally, from B dash to C dash, A dash to C dash. Name it. So this is A dash, F dash, E dash, B dash, C dash and B dash. Now join the respective edges. So A dash to B dash is the first edge. B dash to C dash is the second edge. A dash to F dash will be the third edge. From F dash to E dash, from E dash to D dash, finally D dash to C dash. This completes the hexagon, the final position at 45 degrees. Mark the angle. So this is at 45 degrees. Now take the projections to complete the views. So from E, we'll take the projection line from E and D. So from D dash, also from F and C till F dash C dash projection lines. This will be from the F dash intersection. The C dash projection line intersection will come somewhere here. A dash and B dash will lie on the XY line. So I'll take the projection lines only till XY line. Okay. Name the points. That is my recommendation before you connect them. So this will be E, D, this is C, B, A and F. Always make sure that A and B you don't write it above the XY line, since it is part of the top view. It should be written in the HP space. Okay. Now connect those respective points. ED, C, B and C, AB and F and D. This completes the final view of the hexagonal lamina resting on VP. So thank you for watching. Please subscribe if you have not subscribed yet, and do like the video. Drop in your comments regarding any questions or any doubts that you have. In the next class, we will take up one more a lamina, which is a circular lamina or a hexagonal lamina resting in HP, and then we'll move on to the circular lamina. So please do subscribe and comment. Okay, thank you.